All right, hey Honors Chemistry. So I wanted to make a video on what we've talked about in the end of this past week, which was mole ratios. So what you're going to be experiencing for your pop quiz on Monday is I have to read a question, I have to write the balanced chemical equation, and then I give you a certain amount that you have to figure out how much of another reactant or product is present based off of that amount. So let's look at question number 3. Question 3 says ammonia, NH3, for fertilizer is made by causing hydrogen, so NH3 is ammonia, caused by hydrogen and nitrogen to react at high temperature and pressure. How many moles of ammonia can be made from 0.15 moles of nitrogen gas? So I have to write a balanced equation, and this may not be so blatant to begin with, but it says ammonia is made by causing, so ammonia is a product if it's made, by causing hydrogen and nitrogen to react. Remember, hydrogen is H2, and nitrogen is N2, and I have ammonia, which is NH3. So I'm going to do H2 plus N2 yields NH3. Now I have an extra space here just because I was copying and pasting the template. So H2 plus N2 yields NH3. This is how I would write out the equation for the synthesis of ammonia, and now I have to balance it. I'm going to let you know that in order for me to balance this, think about, okay, I have 2 nitrogens here, only 1 nitrogen here. In order for me to balance it, I'm going to do the guess and check method. I need to put 2 here, and now I'll get 2 nitrogens on both sides. If I put a 2 and I multiply by the H3, 2H3 means I have 6 H's over here. The only way I could have 6 H's is if I put a 3 in front of here. So the balance coefficients here, or the mole ratios, is 3 moles of H2. I'm going to write that below that. 3 moles of H2 reacts with 1 mole of N2 to form 2 moles of NH3. This ratio is constant. Right? So for example, if I have 6 moles of H2, I should have 3 moles of N2. I should have 2 moles of N2. I have a third. Or, let me do the opposite of that. If I have 6 moles of N2, I need 3 times the amount of H2 for the same amount of N2. So if I have 6 moles of N2 times 3, I should have 18 moles of H2. And then differently, the mole ratio between N2 and NH3 is 1 to 2. So if I have, let's say, 6 moles of N2, I should have twice as much NH3, which is 12 moles of NH3. All right, so now let's use the information that's given. It says how many moles of ammonia, which we said is NH3, can be made. So I'm worrying about this column for part of my answer. How many moles of ammonia can be made from 0.15 moles of nitrogen gas? So I was given 0.15 moles of nitrogen gas. That's going in my before box for my nitrogen. So if I give you the amount of nitrogen and I don't give you an amount of hydrogen, we make the assumption that hydrogen is an excess. And remember, excess, I make it stand for excess. Okay? So why is this excess? In the type of questions or equations that we're doing now, if I only give you the amount of one reactant, I'm supplying you with enough of the other reactant, an infinite amount of the other reactant, here is the other reactant, in order to react with it. So if I only give you the quantity of one of them, which is like I only give you the quantity of N2, the other reactant must be in excess. Okay? Now, I am going to completely use up all of my N2, right? It's how much of the reactant I gave you and how much I want to react. So I will subtract 0.5 moles and have 0 moles later. Okay? Now, I need to fill in other parts, right? Now, I jumped at that quickly. You really should do before, change, and then after. In the before section, before my reaction, remember this is just extra space here. Before my reaction starts, how many moles of product do I have? Well, you should know if I didn't even mix these or react these, before I react them, this should be 0 moles. I have no NH3 yet. And then after, as I react them, I use the N2 moles, and I use some of the H2 to make my NH3. So now I have to figure out mole-to-mole ratio of N2 to H2. If you can't do this in your head, I'm going to do it below by showing some work. Remember, the other day in class, I talked about, and if you weren't in class, I reminded us about dimensional analysis. And I'm going to write this on the side here. So for dimensional analysis, it's always quantity 1 times some relationship, and that's going to help me get quantity 2. Sorry, that can't fit. So quantity 1 times some relationship, that's going to help me get quantity 2. And the relationship is quantity 2 over quantity 1. Okay? So if I have some known quantity of something and I want to turn it into another quantity, I need a relationship that will change it into another quantity. And the relationship has the form quantity 2, or the wanted quantity, over quantity 1, the quantity that's given to me. All right, so I gave you 0.15 moles of N2. And eventually I want NH3, but let's do one thing at a, let's say I wanted H2. So I want moles of H2. I'm just doing that. All right. Now for my relationship or my dimensional analysis, I put the units that I have on the bottom. So moles of N2. And the units that I want go on top. Moles of H2. Now, the way that I can figure out the relationship is by using the balanced chemical equation. If I look at the balanced chemical equation between H2 and N2, for every 3 H2s, there are 1 N2s. Or for every 3 moles of H2, there will be 1 mole of N2 that's required to react. Okay? So, what goes in this relationship for us? The relationship, R-ship, is equal to the mole ratio. So, and make sure if you need to, you can rewatch this video about whatever I'm saying. For dimensional analysis, we write the quantity that we have. This is the quantity that was given to us, quantity 1. And I want this quantity. I said I want to get this quantity. So I want this quantity. And so I need a relationship that relates these two quantities. Mole H2, moles N2. And if I do this math, 0.15 times 3, I should get 0.45 moles of H2 is required for this reaction. Meaning for every 0.15 moles of N2, I need 0.45 moles of H2. Okay, and it's negative. Remember, for reactants, it's negative. So for reactants, I use them up. They get negative change. And then, since it's in excess, if I have a lot, which is in excess, and I subtract it from this small number, I still have excess left over. Okay? So I just showed you how I'm relating quantities of reactants to each other. Now I'm going to use that same quantity, and I'm not going to do this dimensional analysis. I'm going to do kind of mental math to show you how I could fill in this part now. Now, I know the mole ratio between N2 and NH3 is 1 to 2. So if I have 0.15 moles, how much NH3 should I have? Well, for every 1 mole of N2, I should get 2 moles of NH3. For every 2 moles of N2, I should get 4 moles of NH3. For every 0.5 moles of N2, I should get 1 mole of NH3. So you can see the pattern here is whatever moles of N2 I have, I multiply by 2 to figure out how many moles of NH3 I'm going to get. So from my 0.15 moles, I'm going to multiply by 2, and I'm going to get plus 0.3 moles of NH3 is what's being produced. I'm going to repeat that quickly. The mole ratio between N2 and NH3 is 1 to 2. So for every 1 mole of N2, I should get twice as much NH3. And if you need me to do the quantity relationship business, it'll be 0.15 moles of N2 times 2 moles of NH3 over 1 mole of N2, and I get, of course, 0.3 moles of NH3. And then for the before and change, you add the before to the change, and you get the after. And I say add, and I do that because I make the change for reactants negative, and I make the change for products positive. Products P positive, reactants are going to be negative. So if I have 0 plus 0.3, I should have 0.3 moles of NH3 that are produced. Okay, that is how you answer question 3 from our homework. All right, so I would suggest rewatching this video if you didn't quite get that. Go back. If you have very specific questions about how to answer question number 3, please let me know. For homework, you're supposed to finish up to question 4, and I've already given you the answer to question 3. You will have a pop quiz on something similar on trying to get a question like this where you make a BCA table and you tell me how much of reactant or product is being produced or used. All right, hopefully this was helpful. Let me know if you have any questions or concerns.